Conductivity. Resistance is the ability of an object to impede the flow of charge. For instance, the object might be a resistor or a light bulb. Resistivity is the ability of a material to impede the flow of charge. For example, aluminium or polythene. Conductance is how good an object is at passing charge. So it's just the other way of looking at something. Resistance, how good it is at stopping charge. Conductance, how good it is at passing charge. And conductivity is how good a material is at passing charge. So for example, copper has a higher conductivity than plastic. The reasons why some materials are better at passing charge than others, and why the dimensions of a material affect its ability to pass charge, are covered on the resistivity video and are not repeated here. On that video you meet this equation, where R is the resistance in ohms, L the length in meters, A the area in square meters, and ρ the resistivity. We can rearrange this equation as ρ is equal to Ra over L, and then the units would be ohms for resistance, square meters for area, and meters for length, giving the units of resistivity as ohm meters. We can do an equivalent equation in terms of conductance and conductivity, and here it is. In this equation, G is the conductance in Siemens, L again the length in meters, A the area in square meters, and sigma the conductivity. Rearranging, we get that sigma is equal to GL over A. Putting in the units of Siemens meters over square meters gives the units of conductivity as Siemens per meter. So you see that resistivity is just the inverse of conductivity. Copper has a resistivity of 1.7 times 10 to the minus 8 ohm meters, a very low resistivity, and a conductivity of 5.9 times 10 to the 7 Siemens per meter, a very high conductivity, meaning copper is very good at passing charge, or conversely very poor at preventing the passage of charge. Polythene has a resistivity of around 10 to the 16 ohm meters, a very high resistivity, and a very low conductivity of 10 to the minus 16 Siemens per meter. Now I'm going to look at the same example that appears on the resistivity video, but in terms of conductivity. A 40 centimeter length of wire with a diameter of 0.5 millimeters passes a current of 0.2 amps when connected to a 1.5 volt cell. Calculate the conductivity of the metal. Well, we have the length of 0.4 meters. The area is pi d squared over 4, which comes out at 1.96 times 10 to the minus 7 square meters. And using conductance is equal to current over potential difference, we get a conductance of 0.13 Siemens. Then sigma is equal to GL over A, where sigma is the conductivity. Putting in our data gives a conductivity of 2.7 times 10 to the 5 ohms per meter. This is the inverse of the resistivity.